Good morning, all of you. Welcome to the class. In the previous class, we had completed Unit 1 and Unit 2. Two units are completed. Today, we have studied or we start Unit 3, which is Graphics Output Primitives. Okay. Now, any picture you can take that can views in several ways. Okay. Shapes and color of the objects can be described internally with pixel arrays or with set of basic geometrical structures such as straight line segment or polygon color areas. Okay. The scene is displayed either by loading the pixel array into the frame buffer or by scan converting the basic geometric structure specifications into pixel pattern. Okay. Like in raster scan system, picture can be defined in the form of intensity of pixel values which are stored in frame buffer, and we need to retrieve the intensity values from the frame buffer and display them on the screen to show the image or picture. Okay. For example, tree, grass, scenes, etc. Similarly, we can use some geometrical structures to define the scenes. Graphics programming packages provide a function to describe a scene in terms of this basic geometric structure is referred to as output primitives. Okay. The geometrical structures are such as point, line, circle, ellipse. Okay. So by using these geometrical structures, we can define a picture or scene. These geometrical structures are also known as output primitive. Now we have some graphics package also have providing some functions to define a scene in the form of the geometrical functions. Okay. Let us see how the geometrical structures are plotted on the screen. Okay. First is point. The point is a most basic graphical element and is completely defined by a pair of user coordinates x, y. Okay. Pixel is a unit square area identified by the coordinate of its lower left corner. Okay. Each pixel on the display surface has a finite size depending on the screen resolution, and a pixel can't represent a single mathematical number. Okay. Origin of the reference coordinate system being located of the lower left corner of the display surface. Okay. Each pixel is accused by a non-negative integer coordinate pair xy. The xy values start at the origin and increases from left to right along a scan line, and y values start at the bottom and increase upwards. Okay, or top. In the above diagram, that means in this diagram, the coordinate of pixel A, B and C are here. Here in this diagram, three pixels are there: A, B and C. A, B and C. The coordinate positions are: A is the 0, 0, that means x axis 0 and y axis 0. In B, x axis is the 1 and y axis is the 4. And in C, x axis is the 4 and y axis is the 7. That means scan line is, x axis is the pixel column values and y axis is the scan line values. Okay. So let us see how the points can be plotted. Just a minute, I will show you how it can be plotted. Generally, the point plotting can be done like this. Okay, this is the x axis, this one is the y axis, x axis and y axis. Okay, these are the scan lines. Or horizontal lines. The horizontal lines represent the vertical values 0, 1, 2, 3, 4, 5, like this. Okay, this is known as scan line values. These are the pixel columns or vertical lines. These column lines will be represent the pixel column values 0, 1, 2, 3, 4, 5, like this. Okay, this is known as pixel column values. Okay, pixel column values are starts from left to right, and the scan line values are starts from bottom to top. Okay, so when we plot a point, for example, the point coordinate position is 2, 3. Here 2 is the pixel column value. Pixel column values. And 3 is the scan line values. Scan line values. Okay. The pixel column value 2. This column. Okay, and scan line values means 3. That means the intersection point of pixel column values and scan line values is known as the point or pixel. Point or pixel. So in this way we can plot a point. Okay. Now let us move how to draw a line or how to plot a line. Okay. When we draw a line, we require two endpoints. Let us take same thing. This is the y-axis and this is the x-axis, this is the y-axis. Okay. Here two endpoints are there. Okay. Now line drawing can be accomplished by plotting the pixel in between these two endpoints. Okay. Now we have different algorithms to find out the plotting point between these two endpoints. When we connect these two endpoints, we can draw a line. So, what is line drawing algorithm? Let us discuss. Okay. Line drawing. Line drawing is accomplished by calculating intermediate point coordinates along the line path between two given endpoints. Okay. Screen pixels are referred with integer values. Plotted positions may only approximate the calculate coordinates. What is pixel? Which are intensified are those which lie very close to the line path. That means between two endpoints, what are the different points are there, we can find out. Or different points in between the line path, we can find out. Okay. Okay. In high resolution system, the adjacent pixels are so closely spread that the approximated line pixel lie very close to the actual line path, and hence the plotted lines appear to be more smooth, almost like the straight line drawn on paper. Okay. In low resolution system, the same approximation technique causes to display with stair steps appearance that is not smooth. Okay. So, some of the characteristics are follow to draw a line. In the different algorithm we have also used to draw a line. To draw a line, we must follow these characteristics. Okay. First is line and points should be specific. Line should appear straight. Line should terminate accurately, not a continuous line. Okay. Line should have constant intensity, and line density should be independent of line length and angle. Okay. To draw the line, we have two algorithms such as DDA line drawing algorithm and second one is Bressenham's line algorithm. So, we have discussed these two algorithms how to draw a line. Okay.